goes back to those first couple of things that we did about algebra, and also brings into it some of the differentiating stuff. So, the first one, this is right back to the start of what we did today. Find quotient and remainder when x squared minus 5 plus 6 is divided by x minus 1. Again, we're right back to this. This doesn't feel like it's core 4, but they're testing the fact that you've understood all of the core stuff that we've done. So, when you did long division on core 2, I used to advise on this to not do long division if you can possibly help it. So if a question only said, find the remainder, then you use the remainder theorem. You just subbed in x equals 1 to find out what the remainder was. If the question just said, find the quotient, then, well, if it said find the quotient and remainder, you have to do it. If it said show that it's a factor, use the factor theorem. You avoided long division if you could. If the question said find quotient and remainder, then you didn't have a choice. You have to do long division on this. And long division, you could potentially expect on core 4 the thing you're dividing by to be more complicated than that. So this is quite kind. Remember how this works? What do you times x by to get x squared? The answer is x. You do that timesing, and then you subtract. The x squared cancels out. X minus 5x minus x gives us minus 4x. Bring down the plus 6. Tim, Lewis, concentrate on this. The x, what do you times x by to get minus 4x?
Minus 4.
Minus 4. Actually do the timesing. That would be a plus 4 there, wouldn't it? And if we subtract, we've got 6 minus 4 gives us 2. So we have our quotient is x minus 4, and our remainder is 2. Okay, presumably, we're going to use this at some point. Part 2. Find the general solution of that differential equation. Right. Well, again, there's a whole other session on this, on differential equations and how you work with those. This paper didn't go for the kind of the big wordy thing about, you know, an oil is dripping out of the tank, all that kind of stuff. If we're going to solve the differential equation, we need to get the bits involving y on the left, because the y is on the top there, and the bits involving x on the right. So the first thing to do is to rearrange this a bit. We need this y minus 5 term to be over here. And we need this x term to be over here. Okay. So that we're ready to differentiate it. We need the y bit over on this side and the x bit over on that side. So it was the wrong way around to start. And now we want to integrate. But before we do that, actually, we're spotting something about this. We've already worked with this here. In part 1 of the question, we divided x squared minus 5x plus 6 by x minus 1. And we got an answer when we divided it. We got that it was equal to x minus 4 and a remainder of 2. So it's x minus 4 plus 2 over x minus 1. Does that make sense? That is equal to that. Because that was the quotient, x minus 4, and the remainder was 2. And it's like when you do 27 divided by 4, when you do that, you get a quotient of 6 and 3 as your remainder. So 27 over 4 is the same as saying 6 plus 3/4. And that's exactly what we've done here. We've said it's that was the quotient, that's the 6 bit, and the remainder was 3 there, the remainder was 2 there, so it's 2x minus 1. Does that make sense? 1 minus 1. And now what we do with differential equations is we integrate both sides with respect to x. So we now integrate to get the integral of 1 over y minus 5 dy, because the dx bit cancels out, is the integral of x minus 4 plus 2 over x minus 1 dx. And the purpose of doing that bit there was to make this something that we can integrate, because this is now not too bad. Here we've got a natural log of y minus 5. Here we've got the integral of x minus the integral of 4 plus the integral of 2 over x minus 1. Plus c. So we've got that. Okay. The reason for doing those stages is actually integrating that thing up there on its own. We didn't have a way of doing that. The top wasn't divided at the bottom, it wasn't a substitution question, it's not partial fractions. We had to use the fact that we'd already divided it to get anywhere with it.
Because you're integrating that with respect to...
Is this all right, Annie? It's no mistake in this?
No. He just doesn't know where the dx went, but it's because you integrated.
The x there.
Right, okay.
It's that when we integrate that with respect to x, you can imagine there being...
Cancels. You can imagine there being
Oh, so
dx
just times the net by dx.
I've done something wrong.
I just times both sides by dx.
With times on both
Isn't
sides by
that
the x,
invisible?
the dx cancels out.
Right, yeah.
With the dy. Does
Okay.
that make sense?
Yep.
Right. This will do as an answer. Okay, the question said, find the general solution of the differential equation. We've got it. There it is. There is our general solution of the differential equation. The last bit of the question said, oh yeah, there we go. The last bit of it so now find something else. Given that y equals 7 and x equals 8, when x equals 8, find y when x equals 6. So y is 7 when x is 8. Oh. That tells us that the natural log of 2 equals 64 over 2, so 32, minus 4 times 8, so 32, plus 2 ln 8 minus 1, plus c. If we rearrange that, the 32's cancel out, don't they? We've got c equals ln 2 minus 2 ln 7. From rearranging there. And so we've got c equals ln, can I write it as 2 over 49?
Yeah.
Is that right? We've got 2 ln 7, so it's 7 squared. And we're subtracting to that. And then it said find the value when x equals 6. So, if x equals 6, we've got ln of y minus 5 equals 36 over 2 minus 4 times 6, so minus 24, plus 2 ln 5 plus c, which is that, And we're supposed to ultimately find out the value of y from this. Didn't say exact, did it? What have we got? We've got -6. Well, here we've got 2 ln. Oh, we've got ln 25 plus ln 2 over 49. So we've got ln 50 over 49. So we've got y minus 5 is e to the -6 plus ln 50 over 49. I think we end up with y equals 50 49ths of e to the -6 plus 5. But it didn't ask for an exact value.
Yeah.
That's ln
I don't
25.
get it.
Sorry, ln 25 plus
Yeah.
ln 2 over 49 gives us ln 50 over 49. And then we've got, if we raise both sides to the power of e,
Oh, you get rid of the other.
you've got e to the ln y minus 5 is y minus 5, and then we've got e to the all of that. And basically, at this point, I would stick it in a calculator
Why is
and
it
add 5 to
28
your
over
answer.
49?
Why is it?
28 over 49. I learned it was 28.
That's 50 over 49.
Oh, right.
So that's the same as that.
Because e to the log something just equals
No,
something.
here. This bit, mine's
Because you raise it
no, not that.
It's anybody done it on a calculator?
How can you multiply the 50 over 49?
Is it?
Because you added it. You add it.
Well, not
When they're added, if you combine them, you times them together, don't you? If it's a log plus a log, if you combine them, it goes to log, and then you times them the two things. So when it's a log minus a log, it goes to
But he's not
one
got
over
any
the
logs
other.
there, he's got pounds.
No, of course it's got logs there. It's got 2 log 5, so it's log 25 plus log 2 over
Because
49.
when you times two things together, you add the powers. So if you've added those powers, you must have times e to the -6 by e to the ln 50 over 49.
But you're asking about the top bit.
And e
Oh,
to
you get
the
log
ln
50 over 49.
So
e
you
to 50
multiply
over
50 over
49.
49.
Okay, so that gave us that there. And we added the 5 because we had the -5 there. And you stick it in the calculator at that stage, and it'll be alright. Great.